Let's look at the application of the intermediate value theorem. For this problem, suppose you invest $1,000 in a special 5-year savings account with a fixed annual interest rate R and with monthly compounding. The amount of money A in the account after 5 years or 60 months is A at R equals 1,000 times 1 plus R over 12 raised to the power 60. Your goal is to have 1,400 in the account after 5 years. Use the intermediate value theorem to show that there is a value of R, which is the interest between 0 and 0.08, and 0 means 0%, 0.08 means 8%, for which A at R equals 1,400. And basically, if the rate is somewhere between 0% and 8% within after 5 years, you will reach this amount or the amount of 1,400. Okay. And if you recall the compounded interest formula, which is A or the balance after t years equals the principal times 1 plus R over N to the power NT. In our case, the R could be anywhere between 0% and 8%. And the T is the number of the times that the interest is compounded within a year. This problem said compounded monthly, that means N is 12, okay? And T is the length of the time, which is 5 years, the length of time, so T equals 5. The P is the invested amount, or P is 1,000. If you replace all the values but R, you would get 1,000 multiplied by 1 plus 0, since R vary from 0% to 8%, so going to be any number between those two numbers. So R over the N is 12 to the power, which is 12 times 5 or 60 for the period of 5 years, which is the formula provided by the problem. And this is a polynomial function. Even though it's not very nice as a normal function that we have seen, but basically this is the function A of R as R raised to the power 60, or that is the highest degree of these terms. So it's a polynomial. Therefore, the function A at R is always continuous, or it's called continuous everywhere. Okay. That means it's checked for condition number 1 of the intermediate value theorem. If the function is continuous everywhere, that means it's also continuous between the given interval, which is from 0 to 0.08. Okay, that's the interval of the R, or the independent variable. And then how about the goal is at some R between 0 and 0.8, you're gonna hit 1,400. So the two endpoints, those are at 0 and at 8%, 0% or 0, 8% or 0.08. Okay. By using the graph to explain a little bit more, that means for the period of 5 years, if the rate could be anywhere between 0 and 0.08 or 8%, the graph, you start with $1,000. So at the beginning, if the rate is 0, you do not have any additional money. So at the end of the 5 years, you still get 1,000. If you have the rate greater than 0, the graph is increasing. So that means you're going to gain more and more from receiving the interest, along the time, along the period of the 5 years. So between 0 and 0.8, at 0, R is 0. So that means 1,000 multiplied by 1 plus 0 over 12 to the power 60. That's 1,000, which is right there. So this is your A at 0. At A at 0.08, or if the rate is 8%, what would be your balance after 5 years? Going to be 1 plus 0.08 divided by 12 raised to the power 60. Put in the calculator. We should get, let's see. We should get 1489.85. Okay. That means over here. So A at 0.08 is 1489.85, or that's the value on the vertical axis. So as you see, this is the function value at point A. This is the function value at point B. And your target, your A at R, which is 1400, is between A at 0 and A at 0.08. So the intermediate value theorem will guarantee you that for any rate between 0% and 8%, gonna return you the final or the balance after 5 years as 1400. So therefore, so by the intermediate value theorem, intermediate value theorem, we can say that there is a value of R between 0% and 8%, such that your balance is gonna be 1400. And look at the better looking graph. That you see 1000 for R equals 0 or 0%. And at the point for R equals 0.08, the number gonna be somewhere up here, like 1489. So 1400 is between the number 1000 and 1489. So the intermediate value theorem guarantees that there's gonna be some R between 0% and 8%, would give you the amount